In this video, we're going to talk about standard form for a quadratic function. Now, there are two different ways that we can talk about standard form in this situation, and we're talking about standard form of a polynomial. So what most of you probably understand standard form to be, that's what we're going to look at here. It might also be called general form. So we are going to look at how we find these key points of a parabola or quadratic function using standard form of our equation. So recall standard form or general form is ax squared plus bx plus c. So we want to find out how it opens, which is given from our equation, what the y-intercept is, which is also given, x-intercepts, vertex, maximum and minimum, and domain and range. So how it opens, again, that's given, and that depends on the a value of this equation. And that's true for all forms for a quadratic function. What is the a value? And we don't really need to know the number, but we need to know if it's positive or negative. So if a is positive, so if it's just an x squared or 3x squared, anything that's positive, that means that the parabola opens up. If a is a negative value, then our graph opens down. The y-intercept is also given. So we know that y-intercept has an x value equal to 0. That's always true. So we can substitute 0 into our function, just find f of 0. So we substitute 0 in for x here and here. We end up with a y value of 7. Well, 7 is just what this c value, or the constant, is in our function. So if you have standard form, that c value tells us the y-intercept. So we just look at that. Now we're going to have to start looking at some steps in solving for some of these other key points of our graph. So our x-intercept, well, that depends on our factors. So since this is standard form, we want to try to factor it if possible. If we can, great, you go ahead and factor and then solve for x. So if we had an example like this, we factor to x plus 1 times x minus 3, and then x could equal negative 1 and positive 3. So those are our x-intercepts. Now a lot of examples are going to have two x-intercepts. Sometimes we only have one. Or we could have 0 real x-intercepts, or x-intercepts that are real numbers. We could have imaginary numbers for our roots. So roots is another name for x-intercept, so I should add that in here. Roots, x-intercepts, or we can also call them zeros. So we get these two numbers. Again, we could have 0, 1, or 2 answers for our x-intercepts. And if we can't factor, we can always just go to quadratic formula. So we just take our a, b, and c value, plug it in, and evaluate what those numbers are. For our vertex, well, we take negative b over 2a, which is part of our quadratic formula. It's this negative b over 2a right here. So to find the x value in our vertex, we use x equals negative b over 2a. So we take the a and b value in our equations and plug those in to find x. Well, now that we've found the x value from that, now we substitute that into our function and evaluate at that value for x, and that's going to give us our y value. So we got an example here. 3 and 6 go into our formula. We get x equals negative 1. So we evaluate f of negative 1, and we get negative 6. So our vertex would be negative 1, negative 6. Now our maximum and minimum depend on the vertex. Since it's a parabola, it either opens up or opens down. So we don't have a max or min for the x values. They both go to negative infinity and positive infinity. So we use the vertex, and if the vertex or the parabola opens up, then that vertex is a minimum value. The graph doesn't go any lower. If the graph opens down, then our vertex is the maximum value because it doesn't go any higher. Domain and range also depend on that min and max. So again, we just mentioned that domain is negative infinity to infinity, which is all real numbers, and this is the symbol we use for that. And the range, if we have a maximum, so again, if the parabola opens down, we have a maximum, so it goes from negative infinity up to that max. And this should actually be a bracket because it's going to include that value in there. And that shouldn't be there, so just kind of ignore that bracket there. And if the graph or parabola opens up, well, then we have, let's see if I can do this without, yeah, I probably can't do it without having that in there. So, ignore that bracket there. But if our parabola opens up, then our vertex is the minimum and it goes up to infinity from there. So again, parentheses next to our infinity and bracket with our min or max. Now we're going to do some examples finding some of these values here for equations in other videos, so make sure to check those out if you need extra practice.